Hi, students and friends. This is your host and teacher Sayyid Ayazuddin Haider, and you're watching Learn and Teach by Sir Ayaz. So I will continue my video session for past papers, and this time I have selected 5070, paper 22 of October-November 2023. Again, I'm not going to read the instructions and the time. The time is 1 hour 45 minutes. It's paper 2 theory. You have to answer all the questions. Periodic table is provided, total mark is 80. So let's start the paper straight away. Here's question number 1. Choose from the list of compounds to answer these questions. Each compound may be used once, more than once, or not at all. Identify the compound that is a waste gas from digestion in animals. So if you look at the choices, we have ammonia, ethanol, glucose, magnesium chloride, magnesium oxide, methane, nitrogen dioxide, phosphorus 5-chloride, polyethylene, sodium bromide, water. It must be methane. Methane is a waste gas from digestion in animals. So I will write methane. Part B, turns blue cobalt 2 chloride pink. Cobalt 2 chloride, hydrated cobalt 2 chloride is pink in color. It's the hydrated one. This one is hydrated. Anhydrated one is blue in color. So it must be water. Hydrated means it's containing water. So it's water, which turns blue cobalt chloride paper pink. C, reacts with ethene above 100 degrees centigrade to produce ethanol. Now, what is reacting with ethene to produce ethanol? This one is a hydration of ethene. This reaction is hydration of ethene, and in hydration we are adding water, so you will write water. Again, the answer must be water. D is a product of photosynthesis. Now in photosynthesis, carbon dioxide and water is reacted. Carbon dioxide plus water is reacted, and the products are glucose and oxygen. So let's see the choices. I can see glucose here. Oxygen is not there, so you write glucose. It's a product of photosynthesis. E contains an anion with a charge of -2. So first of all, I have to pick the ionic compounds here. We have magnesium chloride, magnesium oxide, sodium bromide. So magnesium chloride is containing ions Mg +2 and Cl-. So this can't be the right answer because Cl is the anion here. I'm writing the anion on top, and it's carrying -1 charge. What about magnesium oxide? Magnesium oxide is MgO, and in this magnesium carries +2 charge and oxygen carries -2 charge. This looks correct to me. So this must be the answer for this question. Moving to next question. This question is about metals. A, chromium is a transition element. Sodium is an element in group 1 of the periodic table. State 2 physical properties of chromium that are different to those of sodium. So here's chromium in the periodic table. It's a transition element. So we have transition elements here. These all are transition elements. Where is sodium? Here is sodium. It's a group 1 or alkali metals. So they are asking us to write down differences or the physical properties. They're saying physical properties, not chemical properties. Remember, when they are saying physical properties, you have to quote physical properties. Physical properties means state at RTP, density, melting point, boiling point, rate of diffusion, etc. There are other physical properties also. So I'm not going to in the details of the physical property, the meaning of the physical properties. So what they are saying two physical properties of chromium that are different to those of sodium. Sodium belongs to group 1, which is alkali metals, and you know that alkali metals, they are soft, low melting point, low density, they have less hardness. These are the some typical physical properties of alkali metals. On the other hand, transition metals, they are hard, high melting point, high density. So these are the typical some properties of transition elements. So you can say higher, you can start with higher melting point or hard, higher melting point. You can write high density, higher density. You can even write hard. So I think this is more than enough. They are asking two physical properties that are different to those of sodium. Moving to next part, part B. Deduce the number of protons and neutrons in the chromium atom shown. Here we have chromium atom. There are two numbers you can see. Small number is the proton number. This number is the proton number. And the big number, it's a nucleon number. So for number of protons, I will look at the proton number, which is 24. So you write 24. What about the number of neutrons? You simply need to subtract number of protons from nucleon number. So 53 minus 24. 53 minus 24. 29. 29 is the answer. Part C. Chromium 3 oxide Cr2O3 reacts with carbon and chlorine to produce chromium 3 chloride CrCl3 and carbon monoxide. Construct the symbol equation for this reaction. So for the reactant side, the formula of chromium 3 oxide is written. So I will write Cr2O3 plus, they are saying carbon. Carbon exists as monoatomic. So you write C for carbon. Chlorine. Chlorine belongs to group 7. Here is chlorine. It's a group 7. They all exist as diatomic. They all are diatomic. Group 7 is typical. So you'll write Cl2 for chlorine. What else we have? Now they are saying the products produced here. The product produces chromium 3 chloride, which is CrCl3. Carbon monoxide is CO. It's a 2 marks. It's a 2 marks question. So you need to balance the equation. So let's count the number of atoms of element on each side of this reaction. Cr is 2 on the reactant side, but on the product side, it's 1. So what if I will place 2 before Cr? No, Cr is balanced. What about other elements? Oxygen 3 on the product side, and it's 1 on the 3 on the reactant side and 1 on the product side. So if I will place 3 before CO, so oxygen is also balanced. Now what about carbon? We need to put 3 before carbon, 3C. What about chlorine? 2CrCl3, which means we need 3 moles of Cl2. Now this equation is balanced. Moving to next question, part D. Complete the diagram in figure 2.1 to show the electronic configuration of a sodium ion. Include the charge on the ion. Here's sodium. It's in group 1, which means it will lose 1 electrons. And look at the proton number of sodium, it's 11. After losing 1 electron, it will be left with 10 electrons. So first of all, I'm going to place the charge on the ion. It must be carrying plus charge because it has lost 1 electron. So you can write plus or +1 or 1 plus. All these are correct. Now we need to place electrons in different shells. In the first shell, it must be having 2 electrons. In the second shell, it must be having 8 electrons. As it has lost 1 electron and it is left with 10 electrons. So I will write 2 in the first one. 1, 2. Second one, 1, 2, 3, 4, 5, 6, 7, 8. This will be the final answer for this question. Part E, table 2.1 shows the observations made when 4 different metals are heated in oxygen. So you have metal lanthanum, mercury, nickel, sodium. Now, observation for lanthanum is it's forming a layer of oxide rapidly on the surface but does not burn. Mercury, it does not form a layer of oxide on the surface, which means it's not reacting. It's definitely not reacting. Nickel, it forms a layer of oxide slowly on the surface but does not burn. Sodium burns rapidly. Put the 4 metals in order of their reactivity. Put the least reactive metal first. So for the least reactive, it must be mercury. You see, it's not reacting. It's the only one which is not reacting. So I will start with mercury. Now we can't place sodium after this because sodium is the most reactive one in this because it's burning rapidly. Now we are left with lanthanum and nickel. Either lanthanum will come after mercury or nickel. Now let's check which one of these two is forming layer of oxide rapidly. Lanthanum is forming oxide layer rapidly, so it must be nickel. I will place nickel after mercury. So we'll have nickel here. After this, I'm going to place lanthanum. In the end, we are left with sodium, which is the most reactive one in this series. F. Aluminium is used in food containers and overhead electrical cables because it is resistant to corrosion. Number 1, explain why aluminium is resistant to corrosion. Now it's forming an oxide layer which stops oxygen or water to come in contact or react. You can even write impermeable. So I will write forms an oxide layer. Forms an oxide layer, stops oxygen or water. Or even acid getting in. So that layer now, it's protecting aluminum from further reaction. 2. State 2 other reasons why aluminum is used in overhead electrical cables. Now, one reason must be there that it's having high electrical conductivity and it must be having low density because overhead electrical cables are wires that stage on top now, so it must be having low density. So I will write high electrical conductivity. And then low density. Moving to next question, which is question number 3. The student investigates the reaction of large pieces of calcium carbonate with dilute hydrochloric acid at 25 degrees centigrade. The hydrochloric acid is in excess. A. Complete the equation for this reaction by adding state symbols. CaCO3, it must be in the solid state. You see, all carbonates are insoluble except group 1 and ammonium. So CaCO3 must be in the solid state. HCl is an acid, it must be in aqueous state. So I will add AQ here. CaCl2 aqueous, they have already provided. H2O, it exists in the liquid state. So I will write L for H2O. Okay, that's fine. B, table 3.1 shows the volume of carbon dioxide gas released as the reaction proceeds. Deduce the volume of carbon dioxide gas released after 40 seconds. So we need to see 40 seconds. After 40 seconds, what will be the volume of carbon dioxide? So here's 40 seconds. I am placing a line here for your convenience. The for volume. Okay, so the volume, it must be 31, 32, 33, 34. It must be 34 centimeter cube. So I will write 34 here. Part 2, the student repeats the experiment using the same mass of smaller pieces of calcium carbonate. All other conditions stay the same. Draw a line on the grid in figure 3.1 to show how the volume of carbon dioxide changes when smaller pieces of calcium carbonate are used. Now this time they are using smaller pieces of calcium carbonate. So reaction must be fast. Reaction must be fast. So initial gradient must be steeper. You will start from 0. So initially you are having steeper gradient, and the final volume, it must be forming horizontal line. So can have this. The reaction is fast. Must be meeting here. So this will be the final line. Moving to next part. The student repeats the experiment at 20 degrees centigrade. All other conditions stay the same. Describe and explain using collision theory how the rate of reaction differs when a temperature of 20 degrees centigrade is used. So I will check the initial temperature. What is the initial temperature here? So initial temperature in this reaction is 25 degrees centigrade. Initial temperature 25 degrees centigrade, which means they have reduced the temperature, and so definitely the rate of reaction decreases. Straight away I will start by writing rate of reaction decreases. Rate of reaction decreases. Now use the collision theory and explain what will happen. So definitely is due to the particles having less kinetic energy. Particles have less kinetic energy. One more statement is needed here. So you'll write involved particles with equal or more than activation energy. So here you are having fewer particles having equal or more than activation energy. So you can write this fewer particles with equal or more than activation energy. EA is activation. You can even write fewer successful collision or fewer successful collision. Moving to next part, a sample of carbon dioxide is put into a syringe, gas syringe. The end of the gas syringe is then blocked so that no gas can escape. Explain using kinetic particle theory why increasing the pressure in the gas syringe decreases the volume of gas when the temperature stays the same. Now, in order to explain this, what I will do, I'm going to draw gas syringes so that you will have clear idea what is happening here. So we have two gas syringes here. Gas syringe number 1, gas syringe number 2. These are both are same syringe having different scenario. Now what they said they increase the pressure. So initially if the pressure is this, so I will write P1 for this, V1, P2 increased, we have increased pressure, and then volume must be decreased. They are saying volume decreased. This one must be the you have to explain it on the basis of kinetic particle theory. The kinetic particle theory, we will, in terms of kinetic particle theory, we will talk about the particle. What will happen to the particles? So the volume is decreased. Here we are having particle. See lots of gas particles here. Now you see, now in this case, what will happen? The volume is, when volume is decreased, the particles come closer or are pushed closer together. Particles are pushed closer together. So this must be the final answer for this question. Next question. For a concentrated aqueous magnesium iodide is electrolyzed using graphite electrodes. Predict the product at each electrode. We have aqueous magnesium iodide. What? They are saying concentrated. So aqueous magnesium iodide must be having these ions in the solution. We have Mg+2, H positive, I minus, and OH minus. So at anode, there must be a competition between I minus and OH negative ion. So due to higher concentration of I minus, we will get iodine at anode. So I will write iodine due to higher concentration of iodide ions. What about cathode? At cathode, both Mg+2 and H positive ion will move, but only H positive ion will get discharged and hydrogen gas is produced. Why? Even though the concentration of Mg+2 is high, the reason is that hydrogen is below in the reactivity series, or hydrogen having high ease of discharge, low difficulty of discharge. On the other hand, Mg+2 have high difficulty of discharge or low ease of discharge, or it's highly reactive. So at cathode, what I'm going to write, I will write hydrogen. Reason: H positive ions have high ease of discharge. Low difficulty of discharge. Or less reactive as compared to Mg+2. Part B, molten magnesium iodide is electrolyzed using graphite electrodes. Construct the ionic half equation for the reaction at each electrode when molten magnesium iodide is electrolyzed. Now here we are having only magnesium iodide. So what is the formula of magnesium iodide? So magnesium iodide must be Mg I2, because magnesium belongs to group 2. Group 2 is carrying +2 charge. Iodine belongs to group 7, carrying -1 charge. If you predict the formula between these two, what you will get? You will get this Mgi. Ignore their charges. So these subscripts will be exchanged. So you'll get Mgi2. So the ions, it's for sure, it will be producing Mg+2 and I minus ion. So you'll get I minus at anode and Mg+2 at cathode. At anode, there's a loss of electron. So iodide ion will lose electron, producing iodine, I2. So let's balance the equation. So I will place 2 before I minus and 2 before electrons. What about Mg+2? It will take up or gain electrons. So it's having +2 charge, so it must gain 2 electrons. So I will write Mg+2 plus 2 electrons gives Mg. So this what you will get at cathode. C. Describe a test for aqueous iodide ions. Include the observations for a positive result. Now for iodide ion, we use acidified silver nitrate, and observation must be yellow precipitate. So you write add acidified silver nitrate. For the observation, you write yellow precipitate. Part D. Iodide ions reduce manganese 4 oxide MnO2 to Mn2 plus ions. Here's the reaction equation. 2I minus plus MnO2 plus 4H positive gives Mn2 plus I2 plus 2H2O. Number 1, explain in terms of movement of electrons how iodide ions act as a reducing agent in this reaction. Definitely iodide ions must be giving or losing electrons to Mn. So you write iodide ions lose or give electrons to Mn in MnO2. Mn must be from MnO2. To state the name of the type of reaction that involves simultaneous oxidation and reduction. So the reaction which involves both oxidation and reduction, we call it redox. Party. Phosphorus 3 iodide is produced when phosphorus reacts with iodine. Complete figure 4.1 to show the dot and cross diagram for a molecule of phosphorus 3 iodide. Show only the outer shell electrons. Phosphorus is in group 5, which means it must be having 5 valence electrons. Iodine in group 7, it must be having 7 valence electrons. So in this diagram, one phosphorus atom is sharing 3 of its valence electrons with each iodine atom. The reason is that phosphorus is in group 5 and it needs 3 electrons to complete its valence shell. P needs 3 electrons to complete its valence shell. So for phosphorus, I write the symbol P. I'm using dot for phosphorus. So first I will place electron for phosphorus. 1, 2, 3, 4, 5. Now iodine. Iodine I needs 1 electron to complete their valence shell. Now you have noticed one thing, phosphorus needing 3 electrons to complete its valence shell. So it is sharing 1 of its valence electron with each iodine atom. On the other hand, iodine needs 1 electron to complete their valence shell. So each iodine will share 1 of their valence electrons, not all, with phosphorus atom. So for this iodine, 1, 2, 3, sorry, I'm using cross for iodine. So I will write cross for iodine, not dot. 1, 2, 3, 4, 5, 6, 7. For the iodine atom below, 1, 2, 3, 4, 5, 6, 7. For left hand side, 1, 2, 3, 4, 5, 6, 7. This will be the final dot and cross diagram. Moving to next question, 5A, figure 5.1 shows the displayed formula of compound A. Here's figure 5.1. Number 1, on figure 5.1, draw a circle around the functional group that reacts with aqueous bromine. So it must be having carbon-carbon double bond, which is reacting with aqueous bromine. They are not saying that atom substituted by bromine. They are saying just it's reacting, which means it involves addition reaction. So it must be carbon-carbon double bond. So it's a functional group that is carbon-carbon double bond that reacts with aqueous bromine. A2, describe the color change when excess compound A is added to a few drops of aqueous bromine in a test tube. Color aqueous bromine, it must be orange or red brown, orange or reddish brown. I recommend you to write orange. The reason is that it's aqueous. In aqueous, the color become dim because originally the color of bromine is reddish brown. So in aqueous solution, the color becomes orange. So this must be the preferred answer for color of aqueous bromine. Color after addition of compound A. So it must be decolorized or colorless. Part 3, reduce the molecular formula of a compound A. Now, molecular formula of compound A, we are having carbon atoms here, hydrogen and oxygen. Let's count the number of atoms. Carbon 1, 2, 3, 4. So I'll write C4 here. What about hydrogen? 1, 2, 3, 4, 5, 6, 7, 8. So I will write H8. Oxygen, only one. So C4H8O will be the final formula. Number 4, compound A is a liquid at room temperature. Describe the motion and separation of the particles in liquid. So we are talking about the motion and separation of particles in a liquid state. So it must be sliding over each other. Sliding over each other. You can even write changing places. What about the separation? They are separated close together. They are not tightly packed. They are just close together. Part B shows the structure of compound B. Compound B is polymerized. Draw 2 repeat units of the polymer formed when compound B is polymerized. It will definitely undergo addition polymerization. So you can draw this structure in this way first. We have C double bond C. We have CH3. This is CH3 group. So I write CH3. And this one is also CH3. One more CH3 here. And other are hydrogen atoms. So we'll show the polymer formed from this. Simply remove the double bond and show 2 repeat units. I have removed the double bond and showing 2 repeat units. So this must be the final formula of the polymer formed from this monomer. C. Describe 2 environmental challenges caused by disposal of plastics. Now, they are nuisance. They are responsible for landfills, accumulation of plastic in the ocean. They form toxic gases on burning. Form toxic gases on burning. Landfill or accumulation in ocean. So here's question number 6. Part A. Steam reacts with carbon to produce carbon monoxide and hydrogen. Here's the reaction: steam plus carbon, reversible sign, carbon monoxide plus hydrogen. The forward reaction is endothermic. 1. Explain in terms of bond making and bond breaking why this reaction is endothermic. Now, this question carries 2 marks. So, for mark number 1, you have to mention about bond making and bond breaking. Bond making is exothermic. Bond making is exothermic. And bond breaking is endothermic. Now the reaction is endothermic, which means more energy is absorbed than released. More energy is absorbed than released. You have the reverse argument for this statement, like less energy is released than absorbed. Number two, the transfer of thermal energy in a chemical reaction is called the enthalpy change. Write the symbol for enthalpy change, include the sign for an endothermic enthalpy change. So enthalpy change is represented by delta for the change and enthalpy by H. For the sign of endothermic reaction, you always have to place plus before delta H. B. Carbon monoxide, water, and carbon dioxide are formed during the incomplete combustion of carbon-containing fuels. Number one, name one other substance formed during the incomplete combustion of carbon-containing fuels. Now, in the end, if you continue burning, you are left with carbon. You can even call it particulates, carbon or particulates. Part 2, state one adverse effect of carbon monoxide. It's a poisonous gas. So you write poisonous. You can even write toxic. C. Hydrogen is used in a hydrogen-oxygen fuel cell. Describe two advantages of a hydrogen-oxygen fuel cell compared with a gasoline petrol engine. Now it produces 3 times more energy than petrol or gasoline. So you write more energy produced per gram of fuel. Furthermore, the only product is the water, so there won't be any pollutant. So you'll write water is the only product. This is also advantage, and you can use this water for any purpose. It's pure. It also has high efficiency, so you can mention higher efficiency. There isn't any carbon dioxide produced, so you can write no carbon dioxide produced. Carbon dioxide is responsible for global warming. 7A, dilute hydrochloric acid reacts with aqueous sodium carbonate. So here's the reaction: 2HCl plus Na2CO3 gives 2NaCl plus H2O plus CO2. A student titrates 20 centimeter cube of 0.025 mole per dm cube aqueous sodium carbonate with dilute hydrochloric acid using methyl orange as an indicator. A volume of 15.5 centimeter cube of dilute hydrochloric acid reacts exactly with the 0.025 mole per dm cube aqueous sodium carbonate. Calculate the concentration in mole per dm cube of the dilute hydrochloric acid. So we have the reactants HCl and Na2CO3. These are the reactants HCl and Na2CO3. We need to find the concentration of dilute hydrochloric acid. So I will follow the formula M1V1 by N1 is equal to M2V2 by N2. For the number N, small n represents the number of reacting moles. For example, HCl, I am using N1 to represent the reacting moles of hydrochloric acid. So for Na2CO3, I will use N2. In the same way, I will use V1 as a volume for hydrochloric acid and V2 is a volume of Na2CO3. M1 is the concentration of hydrochloric acid. M2 is the concentration of Na2CO3. We need to find the concentration of hydrochloric acid, so I will write question mark here. What about N1? That's number of reacting moles of HCl. It's 2 from the equation. Na2CO3, 1. Volume of HCl. Volume of HCl is 15.5 centimeter cube. Volume of Na2CO3 is 0.025, 20 centimeter cube. And the concentration of aqueous sodium carbonate is 0.025 mole per dm cube. Now rearrange this equation in such a way that we can calculate M1. So it will become like this. M1 is equal to M2 V2 multiplied by N1 divided by V1 into N2. Placing all the values, M2 is provided, which is 0.025 multiplied by N1 is 2 divided by V1 is 15. Sorry, there's a mistake in this. M2 is 0.025 and V2 is also provided, which is 20 centimeter cube. And N1 is 20. N1 is 2 moles. V1 is the volume of hydrochloric acid, which is 15.5. And the number of moles for Na2CO3 is 1. Now 0.025 multiplied by 20 multiplied by 2 is equal to divided by 15.5. We'll get 0.025 multiplied by 20 multiplied by 2 and divided by 15.5. 0.0645. 0.0645. This will be the final answer. For this question. Moving to next question. B1, state the color of methyl orange in alkaline solution. This is something which you have to learn by heart. It's yellow. Part 2, write the formula of the ion present in aqueous solution of alkalis. It's OH negative. So I will write OH negative. C, calculate the volume measured at RTP of carbon dioxide produced in centimeter cube when 2.65 gram of sodium carbonate reacts with aqueous hydrochloric acid. This is the reaction equation. 2HCl plus Na2CO3 gives NaCl plus H2O plus CO2. Now, they have provided us with the mass of sodium carbonate, which is Na2CO3. And they want you to calculate the volume of CO2. So in order to calculate the volume of CO2, we need the moles of CO2. So in order to calculate the moles of CO2, we need the moles of Na2CO3. So it's very easy. So the number of moles of CO2, Na2CO3 is equal to mass by mR of Na2CO3. Mass is provided, which is 2.65. Now we need to calculate the mR of Na2CO3. We have 2 atoms of Na. So 2 will be multiplied by Ar of sodium. Here is sodium. It's 23. C, carbon. Here is carbon. Its Ar is 12. Oxygen. Here is oxygen. Its Ar is 16. So 2 multiplied by 23 plus 1 atom of carbon. So I will multiply 1 by 12 plus we have 3 atoms of oxygen. So 3 multiplied by 16. So 2 multiplied by 23. What you will get? You will get 46. 46 plus 12 plus 16 multiplied by 3, 48. Adding up these, 46 plus 12 plus 48, you will get 106 as MR of Na2CO3. So 2.65 divided by 106. This will gives us the moles of Na2CO3. 2.65 divided by 106. 0.025. 0.025 are the moles of Na2CO3. If you look at the relationship between Na2CO3 and CO2 from the reaction, it's 1 producing 1 mole. Therefore, 0.025 produces X, or 0.025 moles CO2. Now you have the moles of CO2. We need to calculate the volume of CO2. We know that at RTP, 1 mole of gas occupies a volume of 24 dm cube. Now in the answer they are saying centimeter cube, so I will take centimeter cube, which is 24,000 centimeter cube. So 1 mole of gas occupies a volume of 24,000 centimeter cube. Therefore, 0.025 mole of gas occupies a volume of X. Do the cross. So X is equal to 0.025 multiplied by 24,000. 0.025 multiplied by 24,000. So answer will be 600 centimeter cube. This will be the final answer for this question. Moving to next question, part D. Hydrochloric acid is a strong acid. Define the term strong in the phrase strong acid. Acid which is completely dissociated or ionized in aqueous solution. Acid which is completely dissociated or ionized in aqueous solution. Oxides of nitrogen contributes to acid rain. State one other adverse effect of oxides of nitrogen. It's a non-metal oxide, so it's responsible for acid rain, and other problem included respiratory problems. You can even write of photochemical smog or photochemical smog. That is when it's reacting with the dust particles in the air, and when light fall on it, it becomes photochemical smog. Oxides of nitrogen are removed from car exhaust by catalytic converters. Complete the simple equation for the reaction that occurs in catalytic converter. Now in this reaction, CO get oxidized to produce CO2, and nitrogen get reduced to produce N2. Now balance the equation, so you write 2 before CO2. This reaction is balanced now. Question number 8. A. The equation for the reaction of carbon monoxide with hydrogen at a high temperature in a closed container is shown. COG plus 2H2G, reversible sign, CH3OH methanol G. The forward reaction is exothermic. 1. Predict and explain the effect, if any, on the position of equilibrium when the pressure is increased and the temperature remains constant. Now, when you increase the pressure, the direction of the equilibrium will shift to the side where there will be lesser number of moles of gases. Remember the effect of pressure, it is applicable to gases only. So we have gases here. In fact, we are having gases on both sides of the reaction. So on the left hand side, we have CO plus H2, and we have 2 moles of H2, both are gases. So we have 3 moles of gas on left hand side, and on right hand side we have 1 mole of methanol. So also in the gas state, so I will write 1 mole. So definitely the equilibrium will shift to the right hand side. Position of equilibrium shift to right or to product side. Reason, you write more moles of gases on the left hand side. You can even mention this as volume of gases. More moles of gases on left side, or reverse argument, that is less moles of gases on product side. You can even write instead of moles as volume of gases. Moving to next part 2, predict and explain the effect, if any, on the position of equilibrium when the temperature is increased and the pressure remains constant. Now they are increasing the temperature. Forward reaction is exothermic, which means in the forward direction will favor low temperature. So definitely if you increase the temperature, it will move to the side which is endothermic. So here we have endothermic, reactant side. Product side is exothermic. Fine. So product side is exothermic, reactant side is endothermic. So it will move to the left hand side or to the reactant side. You can mention forward reaction is exothermic or backward reaction is endothermic. Because forward reaction is exothermic or backward reaction is endothermic. B. Methanol reacts with ethanoic acid CH3COOH to produce an ester. Name the ester and draw its displayed formula. So we have methanol and ethanoic acid. We have methyl group coming from methanol. We have methyl group coming from methanol, and alkanoid group coming from carboxylic acid. And in this case, it must be ethanoid. So the name must be methyl ethanoate. Methyl ethanoate. So let's draw the structure of, that's the display formula of methyl group. Methyl group is alkyl group. It must be having 3 carbon atoms. 3 hydrogen attached to one carbon atom. Methyl. 1, 2, 3. This is methyl group. Now they are saying ethanoate. We are getting ethanoate. So it must be joining with the oxygen of carbon. So it will be like this. Bond oxygen, bond C, double bond O. We will also have another CH3. This is methyl ethanoate. The other way you can draw by starting with ethanoate ion, or I'm starting with the ethanoate ion. So in this way, in this case, I will start with the last methyl group of ethanoate, C double bond O, O, then the last one methyl group. Both are correct. Look at the linkage, how it's joining. Look at the linkage, how it's joining. This one is a ethanoate. This one is a ethanoate. And these two are methyl. These are methyl. Number C, methanol is a member of the alcohol homologous series. Describe two general characteristics of a homologous series. This is very easy. You can write any two. Like they have the same general formula, differ from members by CH2 group. There's a trend in physical properties, same functional group, similar chemical properties. So I will write any two from these. Have the same functional group, have the same general formula, or you can write differ from members by CH2 group. Trend in physical properties. Can even write trend in physical properties like melting point, boiling point increases. Same chemical properties, same method of preparation. Etc. Question number 9. A. Table 9.1 shows the melting points and relative electrical conductivities of three elements. We have three elements: calcium, carbon, diamond, iodine. Melting point and relative electrical conductivity of solid is provided to us. Use ideas about structure and bonding to explain the difference in the melting points of diamond and iodine. Now they are saying you have to use the ideas of structure and bonding. So diamonds having a giant structure, while iodine is having a simple structure. So first I will start with diamond. Diamond having a giant structure with strong bonding between all atoms. Diamond has high melting point because it has a giant structure. and has covalent bonding between all the atoms. Iodine has low melting point because it has simple structure. It has simple structure with weak forces or weak intermolecular forces. With weak forces between the molecules. The difference in the electrical conductivities of calcium and iodine. If you look at this table, iodine, it's a poor conductor, while calcium, it's a good conductor of electricity. So definitely calcium is as calcium is a metal. If you look at the position of calcium, here's calcium, group 2, iodine, group 7, which means calcium is a metal and iodine is a non-metal. So calcium must be having mobile electrons. Calcium has mobile electrons. While iodine has no mobile electrons. B. Diamond and graphite are different forms of carbon. Explain in terms of its structure why graphite is a lubricant. Now, graphite has a structure like this. The structure of graphite. One atom, two atom, 3, 4, 5. And there's weak intermolecular force. These are the layered structure. It's in the form of layers. This is graphite. So you see that these are atoms arranged in layers, and the layers can slip or slide over each other. So you write atoms are arranged in layers. Atoms are arranged in layers. Layers slide or slip over each other. Due to this reason, it's a lubricant. See, a compound of sodium, iodine, and oxygen contains 11.62% sodium, 64.14% iodine, and 24.24% oxygen by mass. Deduce the empirical formula of this compound. We have sodium, Na, iodine, I, oxygen, O. Sodium is 11.62%, iodine 64.14%, oxygen is 24.24%. Now, first step, we have to divide their percentage by their AR. We have sodium, here's sodium. AR is 23, iodine, here's iodine. AR is 127, oxygen, AR is 16. So we have 23, 127 for iodine and 16 for oxygen. So 11.62 divided by 23, 0.505, 0.505 for sodium. What about iodine? 64.14 divided by 127.505. Oxygen 24.24 divided by 16, 1.515. Small number, the smallest combining ratio here is of sodium and iodine, and they are same, 0.505. So divide all these by 0.505. So for sodium and iodine must be 1. What about oxygen? 1.515 divided by 0.505 must be 3. So the final formula must be NaIO3. NaIO3. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.